Hello everyone, this is Fab. We are going to start another series of thermodynamics. In this lecture, we will learn about the general gas equations. So let's start. For the general gas equations, we have to know about number of laws which are involved for the formation of that equations, like as Boyle's law, known as the pressure volume law, Charles law, the temperature volume law, Gai-Lussac law, the pressure temperature law, Avogadro law, and finally we will combine that equation in form of general equation. Here you can see that we have taken a particular space where it is filled by different gases or molecule of different gases. You can see that number of molecules randomly moving from one place to another place without losing its internal energy and velocity or an acceleration of these molecules. It shows that in space molecules of the gas will randomly move without losing its energy, either in form of kinetic energy or in the form of heat. They behave or perfectly elastic collision. They behave like perfectly elastic collision, and there is no loss of energy in any form. In other words, it defined as an ideal gas is the theoretical gas composed of many randomly moving points particles whose only interaction are perfectly elastic collision. It is also assumed that these molecules have no attractive or repulsive force between them. It is assumed that all collision of molecules are perfectly elastic. So let's start from the Boyle's law. Boyle was the Irish scientist, chemist, physicist, and inventor. He is largely regarded today as the first modern chemist, also pioneer of modern experimental science methods, and founder of chemistry. He was born in 1627 in Ireland and died in the United Kingdom in 1697. He took a jet tube for his experiment. One of jet tube is filled by a certain gas, and other side is filled with mercury. As he increased the amount of mercury, as you can see that amount of mercury is increased from here to there. As he increased the amount of mercury, it produced some pressure. And the result, the volume of that gas declined from 60 ml to 30 ml. In other words, the product of initial pressure and initial volume of gas is equal to product of final pressure and final volume, where here in this tube, temperature and number of volume will remain same. As per Boyle's law, the change in volume occupied by gas at constant quantity and temperature will result in change in pressure exerted by it. Here you can see that this is a closed system. Whenever in closed system, some pressure is applied in form of weight, its volume is continuously decreasing. You can see in graph, horizontal is a pressure graph and vertical is a volume graph. You can see that the volume of the system is continuously declining when we increase the amount of pressure in form of weight. Mathematically, he proves that pressure is inversely proportional to the volume. Just changing the sign of proportionality and simple mathematical arrangement, we have introduced constant here, where the P is the pressure, V is the volume, and C is a constant. This is the final equation of Boyle's law. Another law was the Charles law, also known as the temperature volume law. He was a French scientist. He was born in 1746 in France and died in 1823 in France. For his experiment, he took 5 balloons and he filled in these balloons different gases. He found that whenever temperature of those balloons increase, the volume of those balloons also directly proportional to its absolute temperature. Here you can see in this system, this is the closed system where volume of the system is continuously decreasing as we have add a burner as we have increased its temperature by using burner. You can see that temperature as well as the volume of the system is increasing. Mathematically, he proves that temperature is directly proportional to volume. By using simple mathematical formulation, we have changed proportionality sign with a constant, and we have this final equation: T by V is equals to C. Here temperature, T is the temperature, V is the volume, C is a constant. In this figure, you can say that the pressure and number of moles are constant. Another law was Law-Gay-Lussac law, the pressure temperature law. He was a French scientist and a physicist chemist. He known for his discovery that water is made of 2 parts of the hydrogen and 1 part of the oxygen. He was born in 1778 in France and died in 1850 in Paris, France. As you can see that in a closed space, whenever the temperature of the system is increased, pressure of that system is also increased. According to his statement, you can see in this graph that whenever we are going to increase the pressure of any system, where temperature of the system will also increase. They are directly proportional to each other. Volume and amount of gas are here constant. P is a pressure, T is a temperature in Kelvin, and C is a constant. Mathematically, P is directly proportional to T. By removing proportionality sign, we have introduced a constant C. Another law was Avogadro law. His name was Amedeo Avogadro. Was born in 1776 and died in 1856. He was an Italian scientist known for his research on gas volume, pressure, and temperature. He formulated that gas law known as Avogadro's law. According to his statement that all gases at the same temperature and pressure have the same number of molecules per unit volume. Here you can see that helium, nitrogen, and methane, their volume is a constant at a constant pressure, temperature, but the mass of these gases are different. But the number of molecules in particular volume remains same, as per his idea that in a particular volume or a given volume or a specific volume, number of molecules of the gas will remain same. General gas equations. Now combination of above discussed law, we will combine them known as a general gas equation, combination of Boyle's Charles law, and these equations is called general gas equations. Here you can see that this is the Boyle's law equations. Just for simple rearrangement, we have here V is directly inversely proportional to the pressure, where T is a constant. This is the Charles law. By simple mathematical rearrangement, we have this final equation. PV is directly proportional to T, or PV, we have removed sign of proportionality with constant, and C is the constant. Thus, the equation, we separate constant and we have this equation PV by T is equals to C. Similarly, P1 of the system, P1 V1 by T1 of the system will be equals to P2 V2 by T2 of the system, and so on so forth. You can see here V specific volume. It is a modified form of gas equation. If the volume V is the general gas equation is taken as 1 kg of gas known as specific volume or denoted by V, then the constant C is the general gas equation is represented by another constant, as you can see that R. Thus, the gas general equation may be written as PV is equals to RT, where R is known as characteristic gas constant or simply gas constant. For any mass in form of kg of gas, the characteristics gas equation becomes MPV MRT. Just dividing N, we have PV final equation MRT. In SI units, the pressure is expressed in 1 bar, which is equals to 100 kilonewton per meter square. The unit of gas constant in SI unit will be Newton meter per kg per Kelvin or joule per kg per Kelvin. The value of gas constant or is different for different gases. Its value for atmospheric air is taken as 287 joule per kg per Kelvin or 0.287 kg per kg kJ per kg per Kelvin. Thanks for watching this video. I hope this will prove helpful for you, and thank you for watching this video.